Hello, today I would like to teach you how you can determine the turning point of a parabola from its completed square form. So let's say I have the equation x squared plus 4x minus 2, and I want to determine the turning point. Now, if you recall, the turning point is the maximum or minimum value this curve can reach. So if it's upward opening, like the one on the right, the far right, it's going to be a minimum value. If it's downward opening, if it's like a sad curve, if you can imagine, this would be the maximum, and this would be the minimum. So essentially, we want to find this extreme point on the curve. And how we're going to do that is we're going to complete the square. Forgot the y here. So let's complete the square. So we get y is equal to x squared plus 4x plus bracket 4 over 2 squared minus 2 minus bracket 4 over 2 squared. Okay? So then you have y is equal to x squared plus 4x plus 4 minus 2 minus 4. Right? So this middle part here, the x squared plus 4x plus 4, this is a perfect square. This is why we complete the square, because sometimes factoring doesn't work, right? For this case, it would definitely work, but for other problems, you're either going to need to use the quadratic formula or you're going to need to know how to complete the square, but that's for another video. Anyway, so since this stuff highlighted in purple is a perfect square, we can factor this as y is equal to bracket x plus 2 squared minus 6. And this is the equation I'm going to try and find the turning point from. So some people call the turning point, this is how I learned it actually, some people call the turning point as the vertex, and that also works. It's the same thing, so just wanted to get that clear. If anybody was wondering, it's the same thing. Anyway, so this stuff in the orange box is actually in the form of y is equal to x minus h squared plus k. Now I know it's kind of scary, but all you need to know is that this is a constant. This is a constant, and that's basically it. So the vertex can actually be found at h comma k, or the turning point. This is how you find the turning point, at h comma k. So if we compare this equation, if we compare the stuff in green to the stuff in orange, can you see some similarities? Well, you can draw the conclusion that k equals negative 6, and then negative h is equal to 2. Let's see here. Negative h equals 2, right? And then, of course, x equals x, and the rest is the same. So if the turning point can be found at h comma k, we first need to find h. We know that negative h is 2. We know that negative h is 2. So what would h be? Well, we need to divide the whole expression by negative 1. And then we get h is equal to negative 2. So I can say that the turning point is at well, h comma k is the turning point. So h is negative 2 and k negative 6. So that is going to be our turning point. Alright, so let's actually sketch this graph. This is going to be negative 1, this is going to be negative 2, this is going to be negative 3, negative 4, negative 5, and negative 6. So our turning point is going to be here. This is going to be the lowest value our graph can reach. How do I know that this is the lowest value? Based on the coefficient of this term, the x squared. if the coefficient of the x squared is negative, if it's like this, the graph is going to look sad. It's going to be a sad graph. If the coefficient is just positive, the graph is going to be a happy graph. It's a smile. It's smiling, right? Because it's positive. Okay, so we want to sketch this graph. Well, just draw a curve here, and then just line this up, and it's gonna look, that is not a good job, it's gonna look something like that. But actually, before we say that we've done this, we need to determine the y-intercept. Well, what is the y-intercept? Y-intercept occurs when x equals 0. So therefore, if we wanted to find the y-intercept, if the question asked you to find the y-intercept of this particular equation, we would just sub 0 into the whole thing. So y is equal to 0 squared plus 4 bracket 0 minus 2. Is that the original equation? Yes, it was. Okay. So then, 0 squared plus 4 comma 0, this is just going to be 0. This is also going to be 0. Anything times 0 is 0. So your y-intercept is going to be at negative 2. So now we can actually draw it on our graph. Alright, after a few moments of trying, I managed to fit the y-intercept perfectly. So this is kind of what this graph is going to look like. So that's how you sketch a quadratic graph. So for an exam, I'd like to give you some steps on how to do it. So one, you want to find the turning point. And then two, the second step, I want you to find your y-intercept. And then, for the third step, this is not really necessary. If you want to, find x-intercepts. So those are the 3 things I would recommend doing in an exam if you wanted to save time. And then, of course, the 4th one is sketch, right? So let's just label that there for sketch. And actually, I recommend drawing the curve first because you're gonna be basing the y and x-axes based off of your turning point. You're gonna be basing this off your turning point. For example, if a graph's turning point was above the x-axis, then the x-axis would be below. But if a graph's turning point was below the x-axis, then the x-axis is going to be above. So I recommend drawing the curve first for that reason. Of course, you can draw the x and xy axis first, but I just find it easier because you don't have to manipulate your graph. And especially because sketching is freehand, right? So you can't be that accurate. So it's better to draw the part that is going to be not symmetrical and not even first before just get it over with, right? So you can adjust the coordinate plane. All right. Anyway, I hope you found this useful. I hope you know how to find the turning point from the completed square form. So as always, I hope to see you in the next video, and goodbye.